The naming convention for ionic compounds is different than the convention for molecular compounds. When naming an ionic compound where the cation is a metal, the first thing that one needs to determine is whether that metal can only form one type of cation or more than one type of cation. If you don't remember which atoms can form only one type of cation, please rewatch the video on ions. If the metal only forms one type of cation, then the name of the ionic compound has the following structure: name of metal plus name of anion. If the anion is a single element, a nonmetal or halogen, then the name of the anion is simply the name of the element modified so it ends in "ide". For instance, table salt has the empirical formula NaCl. Sodium is an alkali metal and can only form one type of cation, Na+. The anion consists of a single element, chlorine. Therefore, the name of this compound is sodium chloride. It starts with the name of the metal, followed by the name of the anion. If the anion is polyatomic, then we just use its name. For instance, one of the ionic compounds that we saw in the previous video was calcium NO3 It consists of calcium, an alkaline earth metal that can only form one type of cation, calcium 2+, and a polyatomic anion, NO3-. Therefore, the name of this compound is calcium nitrate. It starts with the name of the metal, followed by the name of the anion. If the metal can form more than one type of cation, then the name of the ionic compound has the following structure: name of metal plus, in parentheses, magnitude of the charge of the metal cation written in Roman numerals, plus the name of the anion. For example, we looked at two compounds formed by iron, a transition metal that can form more than one type of cation, and by oxygen, FeO and Fe2O3. We know that oxygen can only form one type of ion, O2-. Therefore, based on the formula of these compounds, we can deduce the charges of iron cations. For the first compound, FeO, the empirical formula tells us that the number of iron atoms is the same as the number of oxygen atoms. Because the compound must be overall electrically neutral, and the oxygen anions have charge 2-, the iron cations must have charge 2+. The name of this compound is then iron 2 oxide, name of metal, plus magnitude of the charge of metal cation in parentheses in Roman numerals, plus name of anion. Because the anion is a single element, oxygen, the name of the anion is simply the name of the element modified so that it ends in "ide", oxide. For the second compound, Fe2O3, the empirical formula tells us that the number of oxygen atoms is 1.5 times the number of iron atoms, 3 oxygen atoms to 2 iron atoms. Oxygen anions always have charge 2-, so 3 oxygen atoms accept 2 extra electrons each, for a total of 6 electrons. These 6 electrons come from 2 iron atoms.
so that each iron atom must give up 3 electrons, giving the iron cation's charge 3+. Now we can name the compound. It is iron 3 oxide. Name of metal followed by the magnitude of the cation charge, 3 times larger than the electron charge, followed by the name of the anion, in this case oxide. If the ionic compound has a polyatomic cation like ammonium, NH4+, then the compound name is simply name of cation plus name of anion. So NH4OH is ammonium hydroxide. Note that when naming ionic compounds, we do not use prefixes for the number of atoms of each element, as we do for molecular compounds.